Welcome to Ask and Learn.
Here, the situation is in the figure. You can see that. Now, in the second part, the T dash of sun, S represents sun, is equal to T dash for star, which is ST. So, for this, T dash, delta T dash must to be 0, or the difference of time must to be 0. The two events are simultaneous relative to us. So we are in the spacecraft. This implies that our reference of frame is S dash, which is the reference of the frame of the spacecraft. Is the frame for the spacecraft. In the third case, the time of sun is equal to gamma T dash of sun plus V upon C square x dash of sun, x represent the position, and the time of star st is equal to gamma T dash star plus V by C square x dash star. Now let's take the difference of both the time, or let's say it's a delta t. So delta t is equal to t star minus time of sun ts. So this difference gives us gamma times t dash star minus t dash sun plus v upon c square x dash star minus x dash sun. Let's substitute the values here. So we know gamma is 5 by 3 into t dash star is 0 plus, t dash, the difference of this is 0, whole difference is 0, plus v is 0.8 times c upon c square into the difference of both the x dash is 7.2 ly, which gives us the answer 9.6 times y. Therefore, the sun exploded earlier 9.6 years in frame S.